Okay, so right now we're looking at, I zoomed back out, we're looking at the full unit circle, no longer just quadrant one. And I want us to focus in on these coordinates. So what we did, remember, is we found the coordinates of those three angles there. And we used right triangles, we used the Pythagorean theorem, we took advantage of that to find those coordinates for those 3 points. Now, I want to call your attention to something, and this probably reminds you a little bit of the discussion that we had for this module. Now, if we focus on this angle right here, that angle of 30 degrees and its coordinates, I want you to take advantage of the fact that this unit circle has some pretty awesome symmetry that's going on here. So I want you to imagine we have this unit circle and pretend it's printed out on a piece of paper in front of you. And I want you to imagine taking this unit circle and folding it, what will this be? Maybe hot dog style? Yeah, I think it's hot dog style. I don't know. So you would fold it along this red line here so that this side over here would match up with this side over here. Those two parts would match up. And I'm hoping that you would see that this angle in green would match up with this angle in green. And so I want you to pay attention to those coordinates. So the one for the 30 degrees has coordinates of square root of 3 over 2 for the x. Now look at the x for the angle that is for the 150 degrees, the one that matches up with. Notice it's negative square root of 3 over 2. Now the reason it went from the positive to then the negative is because on this side here, these are all positive x values. Positive x values. Now over here, those are in the negative x values. So while the x coordinate still has the square root of 3 over 2, here on this side, it is negative because those are negative x values there. Now, that y value of 1/2 stays the same. It was positive 1/2 over here, and it's still positive 1/2 over here because these y values along here are positive y values. So that's going to stay the same. Now, let me pick another angle. For example, let's pick this dark blue. If I take this angle, this 45-degree angle, and its coordinates, right there we go. I didn't want to block the coordinates. And let's go ahead and again, I want you to imagine you have this unit circle printed out in front of you, and we are going to fold it, I think it's hamburger style. So we're going to go ahead and fold it along this blue line right here. So if you fold it along the blue line, you would see that that angle of 45 degrees would match up with that angle of 315 degrees. And again, let's focus in on those coordinates. You see that the coordinates look really similar. They have a square root of 2 in the numerator and then a 2 in the denominator. The difference, though, is the y coordinates have changed from, here it was positive square root of 2 over 2, down here it's negative square root of 2 over 2. So the y coordinates changed. And that's because up here, remember, we're dealing with positive y values, but then down in this quadrant, those y values are negative. These are negative y values that we're dealing with. Now, the x's stayed the same. Positive square root of 2 over 2, that stayed as just positive square root of 2 over 2, because remember, the x's, no matter what, are positive. Those haven't changed. So I'm not going to go through every single angle, but I want you to see that if I could really take any angle, and I would see that because of the symmetry, it just matches up with a lot of other angles. So for example, this angle here, if I fold it here, we're going to call this hot dog style, it would match up with that angle there. This angle here, if I fold it hamburger style, you're going to see that it would match up with this angle right here. And again, if I then fold it this way, it would match up with this angle right here. So I want you to see the coordinates are very, 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 very similar to each other. The only thing that changes is whether the x and the y value should be negative or positive, depending on which quadrant you're working in. So for this quadrant 1, the x coordinate's going to be positive, and the y coordinate's also going to be positive. In this second quadrant, the x's are negative, but the y's are positive. In the third quadrant, both the x and the y are negative, and then in quadrant 4, the x's are positive while the y values are negative. So that's why the points, when you first look at the unit circle, a lot of the coordinates look the same, right? We have these 1/2, we have the square root of 3's over 2, the square root of 2 over 2, but the only kind of big difference we are seeing is whether they're negative and positive. So that's something to keep in mind when you're dealing with the unit circle.